Hello everyone. We are going to solve problem 1125, which is smallest sufficient team. Okay. So what does the problem statement looks like? So we are given a list of required skills. No, okay, we're given a list of required skills, and we have to form a team with people who have these skills. Okay, and then we have to ensure that we take minimum number of people so that taking the union of the skills, I am able to get whatever my required skills are. For example, in example one, we are given like we need to form a team where every like at least one person has knowledge about Java, Node.js, and React.js. Okay, now these are the people who have the skills. Okay, so if I take a user 0 and user 2, right? I'm taking 0 index. So the union of them is Java. Union of them is like Java, Node.js, and React.js, which fulfills my requirement, right? That yeah, these people has these requirements. Similarly, let's take example two. Like I have requirements where I need these bunch of skills. Okay, and these are the candidates that I have the option to choose from. Okay, so if you see that if I choose this candidate number one and candidate number two, right? So this guy gives me algorithm maths and React.js, and this guy gives me Java, C Sharp, and AWS. And you see that if I try to take a union of these two people, I get all my required sets. Like I should be like if I take there could be other solutions as well, right? There could be three people whom I combine, and then I get my required cells. Or if I take a union of all these people, I definitely get the whatever my required set is. But the problem student is I need to take minimum number of people so that my required skills are fulfilled, and I have a small number of team to manage, right? So this is the problem statement. I hope you are clear with this. So let's quickly jump to the solution for this, or like try to understand how do we come up with a solution for this problem. Okay, so if you see here, like every in this list of people, like at every step we have two options. If I should be choosing this person, if I should be choosing this person with Java skill, or if I skip this person with Java skill, maybe I might get some other person who might have the Java skills, and I might get and he has some additional fields, right? Skills that might be relevant to me. So like at every stage of my every step where I am standing, like I have a two option to choose whether I should be like taking the person with the skills or should not be taking this person with the skills. And then the function would be calling itself again. Okay, so a tree would be formed like at every step, like if I should be taking this or not, and then again if I should be taking this or not, and again similarly if I've not taken this, then again I have two options whether choose the next skill or not. Okay, and we keep on forming a tree, and then we reach our base condition. Let's say the base condition would be like after choosing certain number of people, all my required skills are fulfilled, right? Or there is no people to choose from, like that is another base case, right? And in that case we return something, and then we propagate the result to the top, and we would be able to and then from multiple results we choose the one that is relevant to us, and then we would be able to get a result. So this is a problem. Let's try to draw a diagram, or do with the diagram, and then understand how do we come to the conclusion, and how do we optimize it and all the problems, right? So let's take the example number one that we just saw, that like, people have Java, Node.js, and React.js. Okay, these are my core skills, and these are the people. For simplicity's sake, I have named Java as J, Node.js as N, and React.js as N, R. Okay, I think I have not copied the problem correctly. The second person should be having second person is Node.js, and third person is Node and React. So this guy is R. Okay, and let's fix this quickly. So this person is R. My bad. Okay, so this person has like three people that we have. All right, now let's try to draw a graph which I'm trying to explain. Okay, so let's start with some. We are here. Okay, let me quickly change the pen. Okay, now, so what I'm trying to say is at every given position I have two options. If I choose the person with a s- if I choose a person with skill, or if I don't choose a person with the skills. Okay, so let's say I choose this person, like person in one with skill J. Okay, and then I have an array where I say that I have chosen this person, and I have an index which mentions that right now I'm pointing at what index. Okay, all right. And in the second scenario, let's say we do not choose this person with J. So let's say this is an array where we are saying that we have chosen this person, so it's empty for right now. and we are at index 0. Okay, now let's move ahead. So again, in the next step, let's say we say that we chose this person, and we decided that we want to choose the second person as well. And then so what we're saying that we are right now we have chosen two-person, and the skills that we have is J and N. Okay, and then in that array we are saying that I have chosen person 0, I have chosen person 1, and I am at index 1. Okay, this is what it signifies, right? And then the next step, let's go to one step back as well. So if I don't choose this person, what would it look like if I don't choose the person at index 1? So it looks like I have J as of now. Okay, and then my skills, like the people that have chosen is only 0, like where I'm just maintaining, and then my index is 1 because like I decided not to choose this person with skill in or Node.js, right? Now let's move ahead. So again, if we move ahead, we say that we decide to choose like I'm standing at this position where I have chosen two people who have skills Java and Node.js. Okay, and my team comprises of two people. Now uh, again, we have two options. If I decide to choose the person with skill 2, if I decide not to choose the person skill 2. Okay, so let's say first case is obviously we choose the person skill 2, G, N, and R. Okay, so you see there was N two times, so basically I just took a union and then have only unique elements here. And then what people have I chose 0, 1, and 2, right? And then I am at index 2. Okay, clear up here. And the next step is, let's say if I don't choose this person, so what would my result look like? Only J and N. Okay, and I would have chosen only 0 and 1, not 2, as you can see, and I'm at index 2. Okay, next what happens? So like if you reach here, so here if you see, we have we have already found, like we have what do you call it, all the required skills that you needed, that is Java, Node.js, and R. Okay, and also like we have reached the number of people that we can take here, right? If it is to like there are no more people to choose from. Okay, so like essentially the code ends, like this flow ends here, and then this will return like when we are able to find someone that is matching our skills. Okay, so what we'll be doing is we will be returning this array that is 0, 1, and 2. So what we know till now, that till now up to this position that we have explored, we know there's a solution where I take all these three people, I will get my skills. Okay, so like and then the problem statement says that always their solution exists. So for sure, like if you take a union of all, if we take everyone from the pool of people, definitely we will and we take a union of it, definitely we will get our answer. Okay, so this is the longest answer that we can have, but we want to have the shortest, like the shortest answer. Okay, and this also from here we don't have anywhere else to go because there is no person to choose from. Okay, so this will return something very large, and this will return something like 0, 1, and 2. Okay, so when the execution of this completes, this will return something very large, so that we are not interested in the result of this will return us an array of 0, 1, and 2. So we know that yeah, these are the three people that we can choose. Now we are also interested, like this was just one part of it, but there are other parts as well, and we are interested in seeing that if we can get more optimal solution than that. Okay, so let's continue with our execution. Now now let's say we are here. Okay, so due to space constraint, I'll be just taking this. Okay, this was index 1. Now let's come to index 2. Okay, so at this point of time, we have chosen only we have not chosen N, we have chosen J, the person with skill J. Okay, now we are at index 2. So we say that, let's say we choose the person with skill 1, skill 2. So what does the union looks like? J, N, and R. Okay, or if we try to represent in a array format, like we say that we have chosen the person with skill 0 and skill 2. Okay, and our index is at 2. So at this point as well, like if you see, we are getting all the required skills that we have, but we need to choose only two people instead of three that we chose earlier. Okay, so this is our base case, and this will return us a result like, yeah, uh, there a solution exists with like two arrays. Okay, and somehow we'll be propagating it back. All right, going ahead, let's see what happens. And as well, like since this is the base case, it will return. If it was not the base case, we would have proceeded further, and then again, like since there are no more than two people, like there are no more people to choose from, so anyways it would have returned. And the other alternative is, let's say we choose this guy, and we decide not to choose the person with skills to person to, right? So would our array look like? That we have chosen only one person, and then our index is a 2, and then since there is no more person to look for, we would just return from here. Okay. And then since this does not give us a valid result, we would return something very large number so that we discard this result. Okay. And this will return some data in some format, and then we know that, yeah, since our base case is there, and then we say that we take index 0 and 2. So if I have I hope I'm making sense still here. Similarly we need to do for the bottom of one as well, but let's try to do it so that we have more clarity of what we are doing. Okay. All right. So we were at index 0, so this was j. uh, I'll be making it down. Okay. Now we're talking about index 1. So let's say we decide to choose that we want to select person 1. Okay. So since we are not chosen anything before, so our array would look like this is one, only one we have chosen, and then we are at index 1. And the other approach is we do not decide to choose anyone, so our array is still empty, and then we are at index 1. All right. um, Continuing down further, then if we decide to choose this person n, like if I decide to choose the person with skill n, now again we have two choices after, and like should we choose the person with skill 2? So the skills 2 were n and r, if I recall correctly. Mm, yeah. So if we decide to choose the person with skill 2, so what does it looks like? We Since n is redundant, so we just choose n and r, and our skill is 1 and 2, and we are at index 1, and this terminates, so it does not return anything. Like we are not able to find anything, so it will return something very large, so that we discard this. And in the other approach, we decide not to choose the person with skill 2. So our array would look like that we have chosen only one, and then we are at index 2, and there's nothing much to do here, so it will also return something very large, and eventually this is also return something very large. That means we have not found a solution in this path. Okay. Continuing here, like we decide to choose the person with skill 2, so we get n and r, which is not and then we have only 2 here, and then our index is 2, we do not get anything, so we return a very large index. And then in the third approach, that like in this one, the other approach is that we don't select anything, and then so our array is empty, where index is 2, we don't get anything, we just return from here, and then this returns something very large. Okay. Okay. Sorry. So coming back to the example, so this guy, since we didn't get anything from here, so this guy will also return something very large, like stating that, yeah, you cannot get any answer here. And then this guy would be returning, since we had received this 0 2, so this guy would be returning 0 2 here, and this guy would be returning 0 1 2 here. Okay. So this person will be choosing that, like which of these two paths we get a smaller result, which that would be 0 2, so like it would be returning 0 2 here. And then and then finally, like this, at this point of time, at here we had result from only one path, so we return 0 2. Okay. So this is how our answer would look like. I hope I made myself clear. Now it would be possible, like some of the part of this solution we are recomputing again and again. Okay. So for that, what we can do is, we this is where dp comes into play. Like if there's some part of this function, like which we have already computed, and again we reach to a state like where we have to compute it again, so we can just cache that data and then return the result and not recompute it again. Okay. The other problem is with this was, even if you're able to solve it, we might end up getting TLE, because like there's a lot of things to take into consider. For example, like as I mentioned, we would be taking only the unique number of unique skills that we need when we combine people. So that would take some additional amount of time, as well as we are handling here in terms of ha- we are hand we are handling in terms of arrays, like mentioning that we took these skills, and what what skills we need, okay, in terms of arrays we are handling, and then again managing that and then propagating that result to the top, uh, could take a lot of time. And then this is not even like we have not even brought deep into the picture right now, because like this was just for the sake of explanation part. Okay, so what I'm trying to say is like if you try to implement this, it's a correct approach. It's this is how we are going to solve it. It's just that the the data structure that we are using right now is not optimal, because it will give us a TLE. Okay, and then so how do we optimize it? Okay, now let's try to look into the approaches how to optimize it. Okay, so if you see here in this example that I just took, I had mentioned J and N as a alias of representing Java and Node.js, right? Or R representing React.js. Now and then our people array is a 2D array, right? Like a person having the skill Java, a person having skill in Node, and person having skill Node and React. Okay, and then since this is a string, so like playing around with a string is itself very time consuming process. Okay, so what I'm trying to suggest is why don't we use some bit manipulation here, so that what we're trying to do with strings can be done very easily with bits. Okay, so just to give you an idea, what I'm trying to say is, okay, let's say this is green. Okay, so now what I'm trying to say is, instead of like saying that my Java is J, I name it. Uh, this is a bit, okay. So I name it 1. Instead of saying Node.js as n, again this is not the decimal. We're talking about bit binary numbers, okay. So I name it 10, okay. Instead of saying React.js as R, we name it 100, okay. So like one means essentially 1 in terms of binary. In terms of integer, this will become 2. In terms of integer, this will become 4, right? Okay, now how do we with this idea, how does my people skill looks like? Okay, so when I say that this is my people, so how does it looks like? So when I say this person 1 has Java, okay, so has Java, it means, again this is in terms of binary, so it will be 1. Okay, it has only Java skill, and the value corresponding to Java is 1. When I say a person has Node.js, what does it mean? Like the binary value for Node.js is 10. Okay, so it becomes 10. When I say a person has a skill for Node and React.js, so I do an OR operation. Okay, so how does it looks like? 110. Okay, so now if we look at these people, we can understand what skills they have. So for example, when I say that a person has one skill has 110, what it means, that I have a lookup map and I say that okay, 1 represents that third index, 1 represents, okay, 0. So let's take the least significant bit. 0 means least significant bit is 0. Okay, so we look at the value for Java, so we know that this the third person, the second person they're talking about, he has no experience in Java. The second least significant bit is 1. We say it is set, so it means that that person has an experience with Java, like Node.js, or he knows Node.js. And the most significant bit is also said, that means that this person has React.js experience as well. Okay, so now you see this, that we have converted our people array from 2D to 1D array, right? And then okay, and at the same time, like we can propagate results more quickly there. Now this we have done. We can also convert our people that we are choosing, that we are choosing from an array to represent to be represented as this bit manipulation only. So for example, let's say when I say that I choose person 0, 1 and 2, okay, so I can, instead of like returning an array of 0, 1 and 2, I can like similar way I can return 1, 1, 1. So that means uh, okay, let me just return it this coming so I'm writing it here. So instead of saying that 0, 1 and 2, I can represent it as 1, 1, 1. What it means, that the least significant bit, that represents the if I have selected the 0% or not. Okay, the second significant like second the element at second position is also 1. That means I've selected uh, the the second person as well. And if, since the like third person is also set to 1, it means that I have selected the third person as well. Okay, so what I'm trying to say is, instead of returning the array here, we would be returning the people that we have selected in terms of bits only. Okay, so that we do not have to handle this array. And then the core logic of solving this problem is still the same. It's just that we are converting the data structures, or the data structures that we are like in our favor. Okay, so that we get the results quickly. All right, or basically we reduce the compute time and then overcome the hard TLA. So basically TLA is like a medium problem with a, sorry, a hard problem is basically a medium problem with a TLA, right? So sometimes like you have to change the data structures, or maybe even the entire algorithm, just to get the um, just to overcome the TLE part. So like here we are going to change the what do you call it, data structures here. Okay, so with this idea in mind, let's try to solve the same problem again. Okay, and then see how we are able to come to the solution, right? And then we will also use the caching part, like the dynamic programming part, where like we want to persist the data and not compute it again. And then uh, that's how we'll be able to solve this problem. All right, so with this idea in mind, let's quickly do that again. Okay, all right, so our skills are, we say that a person has Java, Node, and then React. Okay, so and then we say Java as 1, we say Node as 1 0, as you mentioned, and then this one as 1 1 0 0. Okay, and then the people have skills. First one has Java, second one has, I forgot, I think it's, let's say, Node, and the third one has Node and React, let's say. Okay, so now how do we again how do we like, as we had seen earlier, how do we convert into the format that we need? So we say that this Java means 1, we say that this Node means 1 0, and we say that Node and React means 1 1 0, right? Okay, so with this idea in mind, now let's try to uh, draw our graph once again. Basically it's the same thing. It's just that now instead of like denoting Java as 0, Java as J, we'll be denoting it as 1. Okay, and then Node as 1 0. All right, so starting again, so let's say we are starting here. Okay, and then apologies, and then we say that we choose the person with skill 1 with Java essentially, right? So and what does our selected people looks like? That it means that we have selected the person 1, selected the person with skill 1. We selected the person 1, and now we are at index 1. Okay, and the other approach is like we have not selected anyone, so this is still 0. It means that we have not selected anyone when we are index 0 itself. My bad. Okay, now let's say we decide to choose person with skill 2. So if we decide to choose person with skills 2, so what happens is like so we are saying that we choose this person with skill 2, which is 1 0, and we say that we already have a person, like in our team we already have a person with skill Java with skill 1. Okay, now what we need to do is how do we how do we try to represent this in a number that we know that this person has both Java and Node. Okay, basically, or in a number in a way that we have said that we have selected both this person 1 and person 0. Okay, so if I do an OR operation for these two people, so we get 1 and 1. It means that if and then we have selected these people 1 and 1. It means, and then we are at index 1. Okay, so this bottom 1 and 1 means that we have selected, we have two skills, we have the skills all right, just for easier understanding, I'll make it 0 0 as well. This becomes 0 1 1. Okay, so this least significant bit is 1 here. It means that we have selected the person with skill, uh, we have selected the person like we have this required skill right now. We have this required skill of Java with us. The second significant bit is 1. That means we have the required skill of Node with us. The third bit is still 0. It means that we still don't have the required React.js skill that we need. All right, and here as well, we have shown it as 1 1, like these are binary numbers as of now. Okay, so just this is for easier understanding. While coding, we would be doing light shift, which is essentially the same thing here. Okay, so here we are saying that we have selected person 1 and 1. It means that we have selected the person 1, we have selected the person 0, and we have selected the person 1. Okay, now moving ahead. Let's say we decide we do not want to choose the person 1. Okay, so if we do not decide to choose the person 1, so we do not get this Node.js skill, we have only Java skill, so we represent this as 0 0 1, right? Because we do not have Node.js skill as of now, we don't have React Node.js React.js skill as of now, and we have only Java skill. Okay, and again, this could be this would be represented as we have not selected the person 0 and the person 1, we have selected only person 0. So, and then we are at index 1. Okay, I'm just putting an array bracket so that we know that we are at this stage. Now moving ahead, let's say we decide to choose person 2 as well. So if we decide to choose person 2 as well and we do an OR operation, so this guy has, if you see, this guy has 1 1 0, and we had 0 0 1 as of now, and we do an OR operation, so essentially like all the ones becomes ones and zeros do an OR operation, so we get the we get all ones, and then and we are selecting person 1 as well, so we say that yeah, our people that have chosen is also 1 1 1. Okay, it means that we have selected all these three people. And then you see that since we have all the ones, it means like this is our base case, like when we say that when we get all the uh, basically all the skills. Okay, and then so this would be returning 1 1 1 to us. Okay, so that means that we have a solution where we select all the three people, we would get all the required skills. Okay, so this would be returning some like 1 1 1 to me. And let's see the other part of this guy. Now what does this mean? Like we had selected two people, let's say we decide to not select the third person. Okay, so again what happens is like the skills remains the same because we are not selecting this person. All right, and what does our function parameters look like? We say that we have not chosen the second person, so since we have not chosen the basically the people that we chosen still means the same, our index becomes 2. Okay, and since there is no more people to choose from, so we just return here. And then since this is not the required result that we need, so we would be returning something very large, so that we discard this path. Okay, I hope I'm making sense till now. So again, now since all the children of this path is covered, so it will be, we have a solution with 1 1 1, so we'll be returning 1 1 1 and discarding the other path. Now let's look into the other approach. So up to here, what we had said, this person we our people selected was 0 1. It means that we had selected the person at index 0, we have not selected the person at index 1. Okay, and then we are at now what happens now? So again we have two approaches here, that we decide to choose the person with skill 2. We decide to choose the person 2. Okay, so if we decide to choose the person 2, which is 0 1 1, now what does our relevant skills look like? We have 0 0 0 1, and then we do an OR operation with 1 1 0, so we get 1 1 1, right? So essentially that means we have choose the person, like we have all the three skills as of now. And then since we had and how does our selected per person value looks like? It would be 1 0 1, right? That means we had selected the person with skill 0, we had not selected the person with skill 1, we had selected the person with skill 2. Okay, and then we are at index 2 here. And since we are able to get 1 1 1, we would be returning the user that we have selected 0 1 0 1. Okay, all right. The other approach is obviously that which we decide not to choose the person with skills 2. So our our skill would still look like 0 1 1, that is the previous one that we have. And people selected would also be the same as the previous one, it's just that the index would be increased. And since there is nothing much to do here, and then no more person to choose from, and then this is a very large, this will return a very large number, and we want to discard it. Okay, now both the path have been explored for this guy, so it would be returning us 1 0 1, and this guy would be returning us 1 1 1. Now at this point of time, how do we select out of these two person, that out of these two results that we have, how do we know that which one has a which one should I choose? Okay, so obviously we know that this one is returning saying that if you select all the three people, you would get all your relevant skills. This guy is saying that no, you just need to select two people and still you would be able to get all your required skills, right? So If you look visually, what is the difference that you see here? It means you see that this has an extra one compared to this guy. So what it means is, let's say we write a function and then we have these two steps, and then we say that whichever step has less number of ones, it means we have chosen less number of people. That's what like this means, right? 111 means or 101 means that we have selected this person, not this person, we have selected this person, right? So yeah. So yeah, so essentially you see that if we get um, if we write a function like we compare whichever has the less number of ones, that is our answer. And then similarly we would be exploring down this path as well. I hope you get the idea. Since this will not return the result, so that's why I'm not drawing it. But this would return something very large, and then again this one would be returning us 101. So our result would be like 101. Okay, so and then we can write a simple function like whichever bit is set, we take the value of we set the value of that position to 1, and then whatever the count is at that position, and then return it. So like after this we could simply write a function that would return saying that 0 and 2, right? Like essentially stating that 0 and 2 second bit is set, and that is the result for this problem, stating that we have selected the user 0 and we have selected the user 2. So I hope you're getting the idea how we're trying to solve it. Okay, so with this logic in mind, let's quickly look at through the code so that everything becomes more clearer. As well as like I have not explained the DP part here, but it's very simple. Like what we are simply going to do is, let's say if we know that we have computed some value for it, we are just going to store it somewhere, and then if we know that we already computed for it, we're just going to return it and not call the function again. Okay, again, and what are the base cases here? As I mentioned earlier, the base cases would be like if if we are able to get all the ones that we need, like basically the skills that we need is equal to the our required skill that we had already calculated, which would be all ones. Okay, we say that yeah, we have our result, and then in that case we return the people that we have chosen from. Okay, or else let's say our index is already over the size of the people that we have. In that case we return something very max, so that result is being discarded. Okay, yeah, with that idea in mind, let's quickly look through the code, which is very simple. Okay, yeah, I'll just walk you through this so that you don't have to you understand it clearly. So we have created a long max value, which is like, as I mentioned, we'll be returning a max value in case we don't get our result. This is DP, which will come in a moment. As I mentioned, like we want to have the mapping of skills. So what we simply did was whatever required skills we are iterating over our skills. Okay, and then just doing left shift here. So instead of binary, um, so if you see if you see here like 110, so how, sorry, not this guy. Yeah, so if we see here skills, right, we are saying this as one Node.js, Java, and React. So we are saying Java should be 1 and Node.js should be 10 and React should be 110. Okay, so how we are doing this? We are doing this by doing left shift operation. Okay, so we're saying that we shift the one by these many steps. Okay, so for the first one we're just shifting by 0, so that means 1. We're in the second skill we're shifting by one position, so it becomes 10, and the third one becomes 100. Okay, and then we are also doing a total skills required, which is essentially the so if there are three, so it will be 111. Okay, if there are three skills, if there are four skills, it will be 1111. So 2 power n minus 1, essentially that should be the shorter value. But yeah, and then we have similarly for people skills as well, like you saw, we want to represent Java as 1, we want to represent Node as 10, and we want to represent the person with skills Node and React as 110. It means setting the skill that is true for them. Okay, so for that we created a, instead of using this list, we'll be using an array that we just created. Like we would be using it an array, so we're just basically converting the 2D list to an 1D array. Okay, so how we are doing this is like, what we're doing here is like we're iterating over the people. Okay, and for each person I'm taking what are the skills that guy has. Okay, we're taking what skills that guy has, and I'm taking the value corresponding to that from my bit mask. Okay, so for example, like Java would be represented as one, Node would be represented as 1 0, and React would be representing as 1 1 0 0. Okay, and I'm doing an OR operation. So essentially, like if you see here, Node and React would become like, first if I select Node, I'd get 1 0, and then select React, then I select React, I'd be getting 1 1 0 0, and if I do an OR operation, I get 1 1 0, right? So essentially that is what I'm doing, and then whatever skill that I get, I'm saving it to the to our array. Okay, and then it's a very simple operation of like running a DFS. Basically, at each step we are saying that if I should take this person's skills or if I should skip this person's skills. Okay, so we are passing to three parameters here. That is, one is index, like stating that we are currently at this index. Then this is the current skill, like we till now this is the current skill that we have got. People taken essentially means like these are the people that we have taken. Okay, and then total skills required is something we're just passing, and then people skills is again we are passing something. Skipping this DP part as of now. Coming to RBS cases. So RBS case would be like whatever our current skill is, and we do a we do a AND operation with our total skills. If we get it equals to total skill, essentially what it means is whatever bits that we need for total skills, if the same bits are set in the current skills, that means we have all the required skills that we require, right? So we simply return the people taken here. So just to explain myself again, what I meant is, if you see here, the current skill is 1 1 1. Okay, and our required skill is also 1 1 1. So if I do an AND operation with this 1 1 1 and 1 1, what do we get? 1 1 1, right? That is equals to the required skill. So in that case, it essentially means that we have got all our required skills, and then we simply return the number of people that we have chosen, right? We return the number of people. Where is the other one? Yeah, we return the number of people that we had selected. Okay, so that's what we are doing here. Sorry. And the next line is like, if something is above our like we say that index is greater than the people's length, then it doesn't make sense to go even further. So we're just returning a something very max value, so that we discard this value. Then we created two variables, long and take and skip. So what does our take looks like? We call this DFS method again, uh, stating that our index is incremented by 1, and then our current, we are doing an OR operation with the current person skills. Okay, whatever the current person skill is and whatever the current skill, the person skill and the current skill is, we're doing in the OR operation. Essentially means that my current skill has additionally these more skills that this people skill with index I provides me, if I'm making sense here. And then I'm stating that I'm doing a left shift of index times. It means that I'm selecting this I'm selecting this person as like I'm stating that I have taken this person's skills, um, and saving this in the like people taken, right? It means doing left shift of 1 1 1. So trying to explain myself here, what do I mean is, okay, let's say let's say we are at this position, let's say we are at this position where we have say that we have taken this person, we have not taken the person 1, we have taken the person 0. Okay, now let's say if we want to take the person 2 as well, so what we do is we need to add 1 here, right? So that means 1 0 1, and that means that we have selected this person too. How do we do that? We just do an OR operation and left shifting it by index times whatever the index we have. So we if we do 0 1 and 1 OR operation with 1 0 0, we get 1 0 1, right? So that's what we are simply doing here. And I have written 1L because it's a long operation. So like since it is long, so if it is doing left shift on long bit, you have to write it as we have to append L as well. Okay, and then whatever result I'm getting it, I'm just appending with my current people taken. Okay. So that essentially means that these are the people that I have taken. Similarly for skip is like I just increment the index 1, I do not do anything for the current skill, and I don't choose this person. Okay, my total skill and people is the same. And less bits is just a simple method that I have written, which states that whichever we select the path whichever has less number of people, right? So whatever person will select, if you have taken more people, my one of these would have more number of ones. If I've taken less number of people, one of them would be less number of ones. And what this max means, like this max would have the maximum number of ones that is possible for long, since we're using long here. So I think it's 2 power 64. So like 63, or I guess 63 or 64 bits would be all one. So obviously the max is not selected, if you can understand. Okay, and this would return an answer to me in this result. So like we would be getting something like 101. Okay, when you run this DFS method. And then how do we convert it to 0 to? It's a very simple method. Again, I have written like stating that, um, first I'm just counting how many bits we have, and that would be our result array size. And then I say that, um, if the value at that index is set, I just add that to my result array. If not, then I just um, right shift my result array and then increase my count as well. This is a very simple method which you can understand. All right, so if you run this, you will get your result, but again you will get a TLE because you're not cast your result. So up to here, if you're clear, then converting into TLE is very easy. One approach is definitely you can use an array and things. One is like, if you don't want to put much of an effort, is uh, to convert into DP. The simplest is just create a map with string and the value that you want to persist in that DB for. Right now it's long, long for me, so I just created an array with string and long. And then so what should be our key? So the key of this DP array should be the things that are changing here. Okay, so if you see here, like what we are changing, we're changing the value of index, so index becomes our key. We're changing the value of current skill, so that becomes our key. And then we're changing the value of people taken, right? So the combination of these three, or the uniqueness of these three, becomes the key uh, for this my DP hash map. So what we are saying, that if we get a we come to a state where this value has already been computed, we just return it. So essentially stopping the flow of the tree for going further. Okay, and then and here, like before returning the result, we also ensure that we put the result to my DP map, so that I don't have like so that that is available for next time. All right. Yeah, if you basically this is it. And then if you run this code, so it should work. And then if you submit it also, it should get submitted. So I hope you get the idea how it is working. Feel free to let us know if you have any doubt. Thank you and have a very good day. Bye bye.